Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over how to determine whether work is being done on a system or not by the surroundings when you're given a chemical reaction. So let's get into this. So the first thing we need to remind ourselves uh, before we start to look at these equations, right? So here we're given four sets of equations and we're asked, does the following systems, do any of the following systems have work done on it by the surroundings rather than doing work on the surroundings themselves? So before we can answer that question, let's review something that's going to be helpful. So we know that work is equal to the negative of pressure, constant pressure, multiplied by the change in volume. Okay, so we know this equation. So work is going to be calculated by this pressure, the negative of the pressure multiplied by the change in volume. But if you remember, PV equals nRT. So here we have P times the change in V. So we could replace this with work is equal to the negative in the change in the moles times RT. Let me make that better. RT. And so here, since the change in volume can be affected by the change in the moles, right? Especially if we have temperature is constant and pressure is constant, then moles, and of course R is constant, moles and volume will be proportional. And so we have that under these conditions because we're assuming that pressure is constant here. We can assume that temperature is going to be constant during the reaction. So that's not going to affect anything. So this is useful because now we can use this to determine whether or not work is going to be done on the system or on the surroundings. Okay, so the next thing we need to point out here is what the delta N is referring to. So delta N is referring to the change in the number of moles during the reaction. So here it's going to be equal to the moles of the products minus the moles of the reactants, the total moles of products. So products minus reactants. And so remember, if the change in the number of moles, if that's negative, and we plug that into our work equation, and that's negative, negative means a negative is positive, that means work is positive. And so we have to remember that if work is positive, that means that the system is gaining energy in the form of work, meaning that the surroundings is doing work on the system. Okay? If delta N is positive, then we stick that in here, then work is going to end up being negative. And if work is negative, that means that the system is losing energy in the form of work, meaning that the system is doing work on the surroundings. And you can think of this in terms of the amount of moles or particles, right? So if I lose the number of moles, if I decrease in the number of moles, that's what the delta N means. If it's negative, I'm decreasing. My change in the number of moles is getting lower, right? So that means if the change in moles is decreasing, meaning I'm getting less particles, so then that means that if I have a container that's flexible, less particles means less pressure, which means that the volume is going to shrink, meaning that the outside pressure, the environment, the surroundings is doing pressure, is squeezing and doing work on the reaction vessel, right? So it's doing work on the system. Okay. So again, if I have a positive change in the number of moles, if the number of moles increases, then that means the more particles I have in my system container, right? So if the container is flexible, then those particles are going to push out even more. So that means that the volume is going to increase and it's going to do work on the surroundings. So I hope that helps kind of clarify and give a background on how to answer this question. So now with that in the background, we can then go to these equations and say, okay, what's going on? So here we have a gas, a gas, a gas, and a gas, right? So they're all gases. And over here we have one, and we have one. So over here we have a total of 2 moles on this side. And here we have a 2 and a 2. So over here we have 4 total. So the reaction is going from 2 moles to 4 moles. So then the change in N, products minus reactants, is going to be 4 minus 2, right? And that's going to be equal to 2. So notice that it's a positive change. So that means work, if we plug it into here, is going to be negative. So I have negative work. And so if work is negative, well, that means that the system is doing work on the surroundings. So which of the following of the system that has work done on it? So work done on it, that would be a positive work. So in this case, for A, it's not work is not being done on it. It's doing work on the surrounding. So this would be a no, right? So and no, meaning work is not done on it by the system, and it's actually doing work on the surroundings. All right, let's do the next one. Here we have gas, gas, and gas again. So here we have 1 and 1. We have 1 and 1. So that's, again, on this side we have 2 moles of gas. And over here we have 1 mole of gas. So in this case, again, delta N is going to be products minus reactants. So we have 1 for the products, and we're going to subtract 2 for the reactants, and we get a -1. So here, the change in moles is negative. We plug that into this equation here. Negative and negative becomes positive. So here, work is going to be positive. So if work is positive, that means that the system is gaining energy in the form of work, meaning that the surroundings is doing work on the system. So you can see that here. Notice that if I have 2 moles of gas here, I'm cutting it down by 1/2, right? So that means the volume's probably going to be decreasing by 1/2, right? So it's being squeezed. Work is being done on to the system. So yes, work is being done on it. All right, next we have C. Again, here we have 1 gas on the reactant side, and here we have 1 and 1, so we have 2 of these on the product side, so 2 total, 2 moles total. So again, if we calculate delta N, products minus reactants, the products are 2, reactants are 1, and so here we have a +1, and if we put the +1 in here, then we're going to get a negative for the work. So work in this case is going to be negative. Again, what that means is that the system is losing energy in the form of work, meaning it's going to be doing work on the surroundings. So in this case, no, work is not done on it by the surroundings. It is doing work on the surroundings. And then finally, we have 1 and 1 here. So we have a total of 2 moles of gas over here. And we have 1 and 1 over here. We have 2 moles of gas over here. So we have equal amounts. So in this case, if we put the change in the number of moles, it would be 2 minus 2 equals 0. And in this case, if we plug that in, work is 0. So no work. So no work is being done in either way. The system is not doing work on the surroundings. The surroundings is not doing work on the system. So, but to answer the question, is work being done on the system? No. But the system is not doing work on the surroundings as well. And so that, ladies and gentlemen, is how you attack these problems, from understanding work is equal to negative the constant pressure times delta V, which using PV equals nRT gives you work is equal to the negative of the delta N times RT, and then figuring out the change in moles by the product moles, the total product moles minus the total moles in reactants. Now, this is only for gases. So if you had liquids and solids here, you wouldn't include those because those are not going to produce pressure on the container, right? So if you had a solid here or a liquid, if it was liquid water, then we would not include that. It would just be 1 mole and then 2 moles over here. So remember, if you have solids and liquids, then you ignore those moles and just look at the gases. I hope this is helpful. If it was, if you learned something from this video, if this helped you in any way and you enjoyed the video, then please, by all means, like the video, share the video, hit the like button somewhere around here. Also, do me a favor, subscribe to my channel, hit that notification bell. When you do, make sure you click all so you can be notified by all the videos I put out. Finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a question or a problem you need help with, let me know. If you have a topic you would like me to cover, let me know. I would like to do that for you. Thanks for joining me and have a great day.